A significant number of astronomers have expressed concern that the asteroid Apophis might collide with the planet Earth. On the other hand, when NASA confirmed in 2021 that the asteroid's path was safe, everyone let out a collective sigh of relief. As the date of its flyby grows closer, astronomers are concerned that even a tiny collision with any of the 1.2 million asteroids and comets that are now in our solar system could alter the path that Apophis is on and expedite our mortality. Apophis are something that astronomers just can't seem to get enough of, can they? How likely is it that a collision that could potentially result in death will take place? We'll have to wait and see. Hey there, space enthusiasts. Get ready to blast off into the cosmos with us. Welcome to Spaceverse, where the universe is our playground and curiosity knows no bounds. Join us on an interstellar adventure as we dive into the depths of space, uncovering its mysteries and marvels. From the secrets of black holes to the landscapes of alien worlds, we're here to ignite your imagination and expand your cosmic horizons. With mind-blowing visuals, expert insights, and the thrill of exploration, Spaceverse is your ticket to the ultimate cosmic journey. So strap and hit that subscribe button, and let's embark on an epic voyage together into the vast unknown of Spaceverse. Asteroid fields are everywhere, reminders of how our solar system came to be about 4.6 billion years ago. Most asteroids come from the main asteroid belt located between Jupiter and Mars. These celestial bodies commonly exhibit rapid rotation, erratic movement, and descent across space as they orbit the Sun on highly flattened or elliptical paths. The majority of the over 1 million asteroids that comprise our solar system can be found in close proximity to Jupiter. Due to the gas giant's immense gravitational force, these asteroids will continue to move rapidly and unpredictably in space. Scientists did not start seriously considering the significant effects of an asteroid collision until 2013, even though asteroids have played a crucial role in shaping our planet for centuries. The event commenced in 2014 when a meteor detonated above the Ural Mountains in Russia. Merely observing the video of the incident caused a chilling sensation to run through everyone's body. Up to a distance of 100 kilometers, the meteor's luminosity was so strong that observers perceived it to be even more radiant than the sun. Witnesses reported that apart from the luminous exhibition, the fireball emitted an intense surge of heat towards them. Following the meteor's explosion at a height of around 29.7 kilometers above Chelyabinsk Oblast, a billowing mass of dust and gas spread out over a distance of 26.2 kilometers. Despite the atmosphere mitigating most of the meteor's impact, the explosion still caused severe disorientation to numerous individuals in the surrounding area. Structures in 6 cities in the region required significant repairs following the impact of the shockwave, which impacted about 70 to 200 buildings. Here's a quick comparison to help you understand the danger that could happen. As a result of the explosion caused by the asteroid that crashed in Russia, a total kinetic energy of between 400 and 500 kilotons of TNT was released. That is between 26 and 33 times more energy than the atomic bomb that occurred in Hiroshima. A meteor explosion in Russia was the first time that modern mankind was confronted with the terrifying prospect of a space rock. There is a peanut-shaped asteroid that is still hanging in the galaxy, and we ought to go back to Apophis. On the other hand, the Russian meteor had a diameter of 59 feet and weighed around 9,100 tons. In comparison, Apophis has a width of 1,100 feet. Imagine the amount of kinetic energy that a space rock of that size would possibly possess. If Apophis were to collide with Earth, the resulting impact would undoubtedly be catastrophic. The initial discovery of Apophis was discovered on June 19, 2004 by astronomers Roy A. Tucker, David J. Thalin, and Fabrizio Bernardi. They were operating out of the Kitt Peak National Observatory in Arizona at the time. After scientists became aware of the danger that the asteroid posed to Earth, they designated it as 2004 MN4 and changed its name. Despite the fact that the scientists' predictions of the asteroid's orbital proximity to Earth sent shockwaves through the scientific world, the finding of a new asteroid prompted great excitement within the scientific community. They predicted a 2.7% likelihood that the object will hit with Earth in 2029 based on the visual data that was collected in this year, 2004. Apophis, also known as the God of Chaos, became a common name for it at that point in time. Nevertheless, by the year 2006, astronomers had dismissed the possibility of Apophis. By 2006, astronomers had used meticulous observations and advanced calculations to definitively rule out the occurrence of a collision from Apophis on Earth in 2029. Although the asteroid was in close proximity to Earth in 2068, astronomers were concerned about it still. The future of Apophis after 2029 depended on how the gravitational force of Earth affected its orbit. There was a substantial amount of hypothetical information. From 2015 to 2019, Apophis becomes untraceable due to its extremely close proximity to the Sun. Following its triumphant reappearance on radar, scientists promptly commenced their work and delivered positive news upon their return. Throughout the next century, they took measures to prevent Apophis from colliding with planet Earth. It was comforting to hear that. How significant is Apophis resurgence, and what are the reasons behind it? Despite scientists' confidence in the space rock's trajectory leading up to its close encounter in 2029, there remains a potential for Apophis, one of the 1.2 million asteroids and comets in our solar system, to crash with another object and deviate from its current orbit. In other words, there is a constant potential for Apophis to collide with another celestial body. Paul Wiegert, a Canadian astronomer from the University of Western Ontario, has stated that there are no expected collisions. Despite this knowledge, astronomers remain cautious and take extensive precautions. We are unable to divert our attention from the asteroid. Throughout their inquiry, Wiegert and his colleague Ben Hay from the University of Waterloo in Canada meticulously analyzed every celestial object in the solar system to ascertain if any of them would intersect with Apophis prior to April 2029. They examined two distinct databases, one overseen by the European Space Agency and the other by the Jet Propulsion Laboratory of the United States of America. Initially, the goal was to identify all the comets and asteroids in the solar system that have orbits within a distance of 0.1 astronomical units from Apophis. After conducting a thorough examination of the JPL catalog and ESA catalog, researchers identified a combined total of 376 and 396 objects, respectively. This discovery is highly intriguing as it revealed that both databases included a total of 300 of these entities. Subsequently, they conducted simulations of the selected orbits and determined that Apophis will pass by Earth in April 2029 without experiencing any direct impact from comets or asteroids. This was uncovered subsequent to their simulation of the designated orbits. The likelihood of a space rock causing Apophis orbit to be changed is highly improbable. They did, however, discover something else that has the potential to change the course of events for both Apophis and Earth. Researchers were looking for probable comets and asteroids that could collide with Apophis when they came upon the existence of the asteroid 4544 Xanthus. After traveling little more than 310,000 miles via Apophis in December of 2026, this asteroid will reach its destination. In spite of the fact that 4544 Xanthus and Apophis will not come into contact with one another, it will pass the location where the two will interact 4 hours after Apophis. Apophis is able to be affected by the complementing material that Xanthus has provided because of the proximity of the interaction. If something like that were to take place, increasing the risk of an impact between Apophis and Earth would be a consequence. Think about the effects that might be felt on Earth in the event that the asteroid were to really collide with the planet. It will have an effect on the globe 23 years after that. Since it will have an impact on the Earth 500 kilometers to the west of Santa Monica, the path that it follows through that keyhole is immaterial. The question is whether or not it goes through the middle. If it travels through other areas within that keyhole, the contact point will go further into the Pacific Ocean or be closer to North America. According to Neil deGrasse Tyson, the tremendous tsunami that will be created by the impact of the asteroid will in fact wash away the western shore of the territory of the United States. It is a source of concern for him because the globe will be subjected to the aftershocks of the impact for a considerable amount of time, and that possible damages could amount to $1 trillion. There is a possibility that an asteroid will collide with the ground along the coast of Southern California, according to one assessment. If the asteroid were to crash into the Pacific Ocean, in such scenario, it would cause a series of tsunamis to be triggered. Let us now imagine that the Apophis attack that was expected to occur in Southern California actually occurs. If that is the case, the water flow caused by the tsunami along the west coast should not be particularly strong, and it should only reach about a quarter-mile inland during the tsunami. However, astronomers have ruled out the probability of Apophis colliding with Earth within the next 100 years, ensuring the safety of Southern California for now. What happens after Xanthus comes dangerously close to Apophis in 2026? no one is cognizant of it. It is reassuring to observe that scientists are now more equipped to handle the potential consequences of an asteroid collision compared to their state of preparedness in 2013 when a meteorite exploded above the Ural Mountains in Russia. They have a strong conviction that our existing technological capabilities will allow us to modify the trajectory of a comet or asteroid, so averting a collision with planet Earth. The objective is to impact an approaching asteroid with significant force in order to modify its trajectory around the Sun and redirect it in our desired direction. This is one of the possible possibilities. Another viable method that can be employed is the utilization of a gravity tractor for deflecting asteroids. This approach entails the utilization of a robotic probe that accompanies a celestial object for an extended duration, resulting in the alteration of the celestial object's trajectory due to the gravitational influence exerted by the probe. Nevertheless, due to the lack of rigorous testing, it remains uncertain if these treatments will be efficacious for Apophis. Particularly, NASA has distinct and more efficient strategies in place for dealing with the god of chaos. Apophis will be the focus of scrutiny for the OSIRIS-REx mission, which was initially designed to collect samples from the asteroid Bennu in 2020. Before and after its close encounter on April 13, 2029, the spacecraft now named OSIRIS-APEX will gather crucial data on the asteroid. Scientists are optimistic that they can use their findings to identify the makeup of the asteroid's interior and measure the immediate effects of planetary tides on asteroids. What is your assessment of the likelihood of Apophis colliding with Earth? Will Xanthus maintain its orbital trajectory, or will it pose new issues for our planet? A heartfelt thank you for being here with us today as we come to the end of our journey at Spaceverse. Your support is what drives our investigation of the cosmos. Remember to hit the notification bell and subscribe to our channel so that you can continue to explore with us. See you until the next time we cross paths in the cosmos.